Hello, everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel. So today we'll be going over these algebra problems shown on the screen. All of these problems are equations containing a single variable using addition and subtraction to solve for that particular variable. So then after we solve for the variable, we are going to plug that value that we get back into the equation and make sure that we get the answers as shown. So just to make sure we have the correct value for that variable. So let's go ahead and let's start with number 1, where we have x minus 9 equals minus 26. So what we're going to want to do is, with all of these particular problems, is we want to get the variable isolated, meaning we want the variable to be by itself on either the left side of the equation or the right side of the equation. It does not matter which side it's on. Typically, the left is better because usually you like to write x equals instead of something equals x. But again, it does not matter. It's whatever, which way you want to do it. So what we're going to do is that we're going to have to make this 9 disappear from the left side, and we're going to have to move it to the right side. So since it is negative 9 here, what I'm going to do is I'm going to add 9 to each side of the equation to get rid of the 9 from the left side. So when we do this, we have x minus 9 plus 9 equals minus 26 plus 9. So on the left side of the equation here, minus 9 plus 9 disappears, and then we are left with x equals, which is a good sign because we want to make sure that we get our variable isolated by itself, equals minus 26 plus 9, and then minus 26 plus 9 equals a minus 17. So what we're going to do is we're going to take this minus 17 here, and we're going to double check our answer. We're going to take this x, and we're going to plug it back into the original equation with a value of minus 17. So in doing this, we have minus 17 minus 9. And what does that equal? Well, it should equal 26 if we have the correct answer, and it does equal 26. So that I know, because of this, I know that x equaling minus 17 is the correct answer for problem number 1. So moving right along here, going to number 2. We have y minus a minus 6 equals minus 7. So sometimes you'll see equations written like this where they'll have a minus, a negative, and minusing off a negative just means you're adding a positive number, because this little minus sign goes and forms a positive right here, if you want to remember it that way. So now we have y plus 6 equals minus 7. And just like before with the first equation, we want to get our y variable isolated. It doesn't matter what the variable is, if it's x, y, n, t, a, you treat it all the same. We want to get it isolated so it's by itself. So I'm going to have to move this plus 6 to the other side. And anytime you move something to another side of an equation, you use the opposite sign. So I'm going to minus 6 from each side. So I have y plus 6 minus 6 equals minus 7 minus 6. The plus 6 minus 6 will cancel each other out on the left side. And then I'm left with y equals minus 7 minus 6. And then minus 7 minus 6 gives me a minus 13. So just like before, what I'm going to do, I'm going to take this y that I have of minus 13 and plug it back into the original equation to make sure that it does in fact equal minus 7. Oops, sorry about that. So then we have minus 13 minus a minus 6 equals a minus 7. And you can also write this minus minus 6 like this. It's the same equation. So 13 minusing off a minus 6 is essentially 13 plus 6, which does in fact equal a minus 7. So then I know, because the equation is still true, comes out to be minus 7, that y is in fact minus 13. Okay, moving on to the third equation here. And this one we have minus 8 equals 6, minus 8 equals x minus 6. And this time the variable's on the right side of the equation, and this is just going to show you that it does not matter if the unknown variable is on the left side or the right side. You treat the problem exactly the same procedure. So just like with the previous two, we want our variable isolated. Well, I have minus 6, so I want to take that minus 6 and I want to get rid of it on this right side. And in order to do that, I have to add 6 to each side. Oop. I have to add 6 to each side. So I'm going to end up with minus 8 plus 6 equals x minus 6 plus 6. Once again, these numbers will cancel. Minus 6 plus 6 gives me 0. So then I have minus 8 plus 6 is equal to x. And then minus 8 plus 6 gives me minus 2 is equal to x. And this is okay to write it like this. It's just how particular your teachers or professors are when they're grading this. Most of the time you will see it with the variable on the left side. So just switch around just to be safe. But either one of these is perfectly fine in the real world application in solving this. So we have x equals minus 2. And what we're going to do is we're going to take that minus 2 for x and plug it back into our original equation to make sure that we do get minus 8. So we have minus 2, minus 6, and that does in fact equal a minus 8. So because that equals the minus 8, I know that my answer of x equals negative 2 is the correct one. All right, one more to go. And this time we actually have a variable of n. And once again, this is just to show you that it does not matter what the variable is, what letter it represents. You treat all these problems exactly the same manner. So this time we have n plus 72 is equal to 63. So we're going to isolate n on the left side of the equation. So we need to subtract off 72 from each side. So I end up with n plus 72 minus 72 equals 63 minus 72. Let me scroll down here a little bit. So the 72 will cancel with each on the left side here. And I'm left with n equals 63 minus 72. Well, 63 minus 72 gives me a minus 9. And finally, what we're going to do is we're going to plug that back in for n up here. And we have minus 9 plus 72. And that does, in fact, give us 63. So I know that my final answer of n equals minus 9 is the correct one. And that's how you solve these problems. And if you want to solve them a little bit quicker, you can memorize this rule if you want to. So let's just look at number 1, where we have x minus 9 equals minus 26. Instead of writing it like this, where you do plus and plus on each side, what you can do is you can just go ahead, and let me switch colors real quick. What you can do is just go ahead and you can move this to the other side of the equation right away. And what happens here is that when you move a number or a value to the opposite side of the equation, you want to use the opposite sign that is attached to it. So for instance, negative 9 moving to the opposite side, this equation would become then plus 9 on the opposite side that it originally started at. And then as you can see, well, that's my equation that I have right here then. You save a few steps in doing that. Once you get better at it, you can start doing this. And then just for more practice, looking at number 3 here, where you have minus 8 equals x minus 6. Going to take this minus 6 and move it to the opposite side. So we need the opposite sign. Well, the opposite sign of a negative is a plus. Once again, there's that equation right there. Saved a step or two. And it just depends on what you're comfortable with doing. It's just a little bit faster, and it's an easier one of the easier types of rememorization tools that you can use for algebra problems is just taking your number, and if you want to move something to the opposite side, you use the opposite sign that is attached to it. So I hope this was helpful, and if you want to see more problems solved in this variety, please check out the other videos on this channel. Thank you for watching, and I hope you have a great day.